Hello everyone, welcome back to my YouTube channel. My name is Rajat and today we are going to touch upon the normalization concept. And currently we are pursuing our this playlist where we are covering MySQL and all the concepts of SQL. So the topic for today is going to be normalization, and it's a very important topic, so please make sure that you understand the concept properly with focus. Okay. So what is normalization? Number one, see, normalization is a process of designing the system so that you can reduce the redundancy and dependency on the data. Let me make a note of that. Reduce redundancy and improve performance. Now, how you'll improve the performance when you have a simple table? Okay, so this is a big table. Let's say in this table you have 100 rows. So this is an efficient way, or this is an efficient way that I make 10 tables, small, like 5, and similarly 5 more. So I have 10 tables and I keep 10 observations in each of these tables. So this is a process of normalization. The goal is basically to ensure that the data is efficient and eliminated any anomalies in the data. What is anomalies? By the end of this video, you will cover this. You'll understand. So anomalies we need to remove. Also, for easy data maintenance. So this is a second reason why we use normalization. Now, generally, there are types of normalization, okay, which you can see on the top also. There are normalization forms. So majorly there are 4 types, as you can see on the top, guys. Okay. Now, there are some specific pointer which I want all of you to note down before I give the example. Now, I hope you understand the normalization process. At least from the database perspective, it's very clear to all of us, like that this is a process to reduce redundancy and bifurcate a simple data into some chunks so that we don't have a dependency only on one chunk of data. Now, also to avoid any anomalies like unusual behavior of data, that is anomalies. Okay. Now, easy data maintenance, because now you have 10 chunks, so maintaining 10 observation at a time for database is also very easy. Now, as I said, there are some types of normalization. So one is 1F, then you have second normalization form, then we have third normalization form, and then the fourth one is the full form of BCNF is Boyce-Codd normal form. So let me write it. That is Boyce-Codd, and normal form is easy. Normal form. So these are the 4 type of normalization which we have in MySQL. Now let me brief you about the major points about each of them. Like in first normalization form, you just need to remember this, that each column contain only identical data or atomic data. Each column have atomic data. Now column, all of you understand what is the meaning of column. I explained it in previous video. So any container of data, let's say name, where we have so many name in a table. One name is Rajat, then we have Sumit, then we have Akansha, and so and so. So this is a container and also called as column. Okay. So now that is number 1. Then second thing is no repeating group of no repeating group or array. So this is the second condition you should note about the first normalization form. Okay. And also the third is no ordered, basically dependency. Okay. So on the order in the column, there is no dependency. So let me write that. So guys, this is dependency. Okay, sometimes my spellings are not so correct, so please bear with me. So this is the quality about the first normalization form. Then if we talk about the second normalization form, it meets first normalization form, like all the condition of first normalization form. Also, any non-key columns are fully functionally dependent on the primary key. So we can write it in such a way that it meets first normalization form condition, which is each column have atomic data. Also, in addition to this, all non-key column are fully functionally dependent. All non-key columns are dependent on primary key, which I explained earlier also what is primary key. So I think this is very clear. Okay, now the second point about this will be no partial dependencies. No partial dependencies. What does that mean? That no key attribute depends on only one part of the composite key which you will create. Now if you have any doubt on the primary key concept, okay, please refer the same playlist. There are some videos initially when I started this course. So this is about the conditions of second normalization form. Okay, now the third normalization form, very easy to remember. First point, it meets the requirement of all this, like first and NF. So we can say meet to NF requirement. That means each column have a atomic data. Also, all non-key columns are dependent on the primary key. Now, in addition to that, no transitive dependencies. Meet second NF and none transitive dependencies. This is the point to remember about 3NF. No, and the second point will be no key attribute should be dependent on non-key attributes. So no key attribute should depend on key attribute. That means your primary key. So this is about the third form of NF. Okay. Now let's talk about the fourth one. So this is something you can say as a advanced version of third form of normalization. Simple guys. Okay. Now in this particular one, how you'll define this? That it meets the requirement of 3NF. Number one, meet requirement of third form of normalization. That is number one. And for every functional dependency, the determinant must be a candidate key. For all these concepts, guys, this is nothing new. Okay, if you're not getting any particular point, please start this playlist from starting, because there are so many things which I have covered earlier. Okay, so just remember that all these concepts are already covered somewhere in the previous video. If you still have any doubt, please do the comment. Okay, now what I am writing here, for every functional dependency, every functional, for any functional dependency, the determinant must be a candidate key. The determinant must be candidate key. So this is very simple. Okay, all these explanation I'm giving you as easiest way as possible. Okay, then second condition for BY normalization form will be that it stricter version of third NF to handle basically expectations you have where 3NF may not be enough. So we can say it's the enhance version of third form of normalization. That's how we define them. Okay. On that note, let me take some of the examples so that we can discuss more. After the example, you will be fully clear, because I know sometimes these concepts are bit tough to understand. So let's talk about the example number 1. So in the case of first normalization form, let's say you have a table. In this table, you have two things. So let's say one is your student ID, then second is your subject. Then student ID, there are two students, let's say. Let's take an example, 1 and 2. Roll number 1, roll number 2. So roll number 1 is good in maths and physics. Roll number 2 is good with English. I hope my spellings you can understand, but I am saying also, so I think you should be good. So maths and physics for roll number 1, then roll number 2 is English and science. Now, when I apply first NF to this table, so what will be the output? That is interesting. I'll create a bigger table now. First normalization form will go in this way. So this will break the data. ID will be there and then subject will be there. But what it will do, it will put 2 entry for roll number 1 and 2 entry for roll number 2. In the first entry, it will write math. Then it will write physics. Then in this one, it will write English and then science. So this is your data after applying the first form of normalization. I hope this is making more sense, which I explained up there also. If you see, each column have a atomic data, no repetitive group or array, okay, and no order dependency. So all these conditions are satisfied here. Now in the case of second normalization form, how the example will look like, let me show you that. For that, I will create one more table again. This is an example of second form of normalization. So here we have 3 columns. So second NF, this is an example. So we have ID and then we have again subject, and after subject we have teacher. So let's say ID 1 and ID 2. There is subjects maths and we have English. And let's say Mr. Amit teaching maths and Miss Malini is teaching English. Now there was 2 conditions for second form, like it meets the first NF, okay, then all non-key columns are dependent on the primary key and no partial dependency. So see guys, one more thing here, teacher is dependent on subject because each teacher have a specialization. So if you see, Malini cannot teach mathematics, okay, similarly vice versa. So how, after applying the 2NF on this table, when I apply second form of normalization on this table, how the data will look like. And before that, one more concept. What is composite key and how that basically works? If you combine the ID and subject, let's say 1 maths. So this is a composite key, which is a combination of a primary key and another key in the data. So in this case, if I break this composite key, so we can write the data in a simple form. Let's say I will create a table where again 2 columns will be there. So this single table will be divided into 2 tables. In one table, you will only see student ID and subject. So here it will come 1 and 2. Here I will write maths and English. In the second table, this first column, it will talk about what? It will talk about subject, and this second column will talk about teacher. So I will write math and English here, and the name of the teacher, which is Amit and Malini. So that's how basically second normalization form breaks the data. So you can see there is no dependency, no partial dependency. That was a condition which I told you in the second form of normalization. Now let's move on to the third form. For that example, if I enhance this same table, okay, I had ID, then I have the subject, then I have the teacher. Now I have the mobile number of the teacher. So that is a bigger table. Now I have, let's say here, one ID and then second ID. Then subjects are maths and physics. Teacher is Mr. Amit and Malini. The number for Mr. Amit is 998877. Just a dummy number. And for Malini, you all need the number of Malini, so I'll keep it 100. So that is the number of Miss Malini. Now, after applying the third form of normalization, how the data will look like. So you will have a ID column. So number one, so it will again break the table into two tables, okay? So now in the output, you will have two tables. So first table will talk about student ID again, and then the subject and the teacher. Now, if you see, this mobile number directly does not have any significance on the ID. It has a significance if you combined teacher plus mobile number, that will come as a composite key. So in this case, in the first table, I will talk about the student ID I will take, and then subject and the teacher name. In the table number 2, this is something you need to understand. In table number 2, you can see a relationship between teacher and mobile. So in the table number 2, you will see this data. So here what will come? 1, 2. Here what will come? Maths and physics. Here what will come? Amit and Malini. Again in the table number 2, Amit and Malini and their respective mobile number. So that's the example of third form of normalization. Now to make you understand the last topic for the day, that is BCNF. So for that, I need to create a table again. So let's say I have a ID, then I have subject, and then I have department. Let's use a different data. So in the ID, I have, let's say 1, 1 and 2. Then I have maths, English. Again for roll number 2, let's say we have maths. They are from department. Let's say he's from science department, then from arts, and again from science. So if you apply the BCNF, again this will break the table into two forms. So the first table will contain subject and department. All the values which are there, it will not come like this. So only one entry for one value will come. Math will only come in a separate table, and then it will come English. Now if you see, so this is a repetitive value, okay? This is math with science. Similarly here also it's math with science. So in the form of BCNF, it will count as a 1. So math is with science, English is with arts. This is your table 1. Simple logic, guys, okay? So just understand how I am dividing the data, so you will get it clearly. Now the second table, what it will contain, it will have a ID and then subject. Now here you will not have two rows like this. This is a normalization when I was talking. If you go up when we were talking about the concept, so what I did, like I was breaking one into multiple chunks. So here also you can see what we are doing. We are dividing a big table into multiple data, and the relationship between the column is very important. Now in this, the value for the second table will be 1, 1 and 2. Again here math will come, and then English will come, and again maths will come. So guys, if you see, this is the BCNF, okay? Now, one very important thing before I wrap up this video, that you should know the concept of candidate key and this composite key. So I think that is pretty much clear to all of you. And on that note, I would like to wrap up this video. If you have any question, concern, any thoughts on this, so please put it in the comment section. If you like the video, please hit the like button and please subscribe to my YouTube channel. I'll see you in the next video. Thank you so much, guys.